In this video, I'll be covering question 1, part B from the 2021 AP Calculus AB Free Response Calculator Required portion of the test. I cover A, B, C, and D each in their own individual little videos because they're kind of their own individual little problems. So this question will just be focusing in on question 1, part B. Question 1, part B wants us to approximate the value of this integral right here using right-hand Riemann sums with 4 subintervals. The first thing that I do when I'm being asked to do a Riemann sum off of a table of values is I pull that table of values out into a number line. It really kind of helps me digest the information a little bit easier than trying to look at it in terms of this table here. So I start off and I use what you would consider to be your x values, the top row here, to lay out where my number line is. So I start at that first value of 0, and then I would go 1, 2, 2.5, and then at the end I've got 4. And then after I've got the x values laid down, I come and put the y values that go with them above them, because those y values are where you're always grabbing those heights from when you're trying to set up your rectangles on a Riemann sum problem. So at 0, I've got a y value of 1. At 1, I've got a y value of 2. At 2, it's 6, and then so on down the line. So at 2.5, it's 10, and then at 4, it's 18. Then I come back and I label these gaps here. I call it A1, A2, A3, A4. That does two things. It shows me how I'm going to break this down into bite-sized little chunks, and it also makes sure that I've got the right number of intervals, which is 4. So here I should be going to A4, and sure enough, I am at A4. Now I go into what I just sort of refer to as my assembly line process. I'm now going to come up with area formulas for each one of these gaps here. So A1, A2, A3, A4. When we're doing the Riemann sum problems, remember that the Riemann sums are always the area of a rectangle. So this is area of a rectangle, which is going to be base times height. The base in here is always what we refer to in this standard notation as your delta x. It's your gap on the bottom of each of these. And when I lay it out on a number line, it's a lot easier for me to now see what my delta x's are. So that goes 0 to 1, so my delta x on this one would be 1. Here I'm 1 to 2, so that's still going to be a delta x of 1. But now, this is where I think the number line is helpful, is you see that you don't have a standardized gap here. That's kind of the trap they want you to fall into, is most of the time when you were practicing these, you usually had a standard gap, a standard base on the bottom. And when you've got a table, that gap can change from section to section. So it's helpful to see it this way. So then I've got a delta x on this last gap, 2.5 to 4 of 1.5. And so now I've got all of my bases in place. Then from there, what I need to come do is I need to come find my height. And my height is going to come from my y values. It's going to come from my function values. The difference between this problem and most of the traditional ones that you see is what they want us to approximate here isn't just the f of r portion, it's a little bit of an additional piece. They want us to do r times f of r. And so that's how we're going to find our heights on this one. Again, on traditional problems, you very often just saw them wanting you to use the f of r portion to find your height. This time, because that was the integral we were trying to estimate, we're going to need to be using r f of r. So I come through, and what I would do in this situation, again, it's sort of an assembly line, is I'm going to have a slot here that I'm going to plug in my r value for, and then I'm going to have a slot here that I would be plugging in my f of r value. So I would come through, and I would say, okay, well, this is what I'm trying to accomplish. And, you know, the more of these that you do, the more you can maybe skip a little bit of my process. But I just kind of want to lay out to you what's happening here. As I come in now, I remind myself I'm looking at a right-hand sum. So I start off on A1, and I know that I've got a left-hand portion and I've got a right-hand portion. And so on the right side, I'm going to be looking right here on A1. So the r value, that's the x value, remember, that's going to be 1. The f of r value, that's going to be my y value that's there. That's going to be 2. right? That's the y value on the right-hand side. So then I move on to A2 and I kind of play the same game. I've got a left endpoint and I've got a right endpoint. On A2, the right-hand side would be over here. So the r value is going to be 2 because that's our x value. Then my height is going to now be 6 in this situation. Moving on to A3, I've got a left side, I've got a right side, and again, I want the right-hand side. So the right-hand side, my x value is now 2.5, my r value, and then my f of r value is going to come out to be 10. And I do it again on A4, last time. Left-hand side, right-hand side. I want the right-hand side, so I'm using this information over here. So the r value, that is our x, that's our 4. And then the height here for the f portion is going to be 18. Now from there, what I would do is I come in and I now multiply all this stuff out together. So then this is where having the calculator is going to be handy sometimes. So the first one I can kind of do pretty straightforward. 1 times 2 times 1 times 1 times 2 is going to get me 2. 1 times 2 times 6 is going to get me 12. Then the next one's where things maybe get a little bit funky on us. We get 2.5 times 10 would be 25, and then half of 25 would be 12.5. But again, if you want to, feel free to use the calculator, right? So then on to the next one, we end up getting out, and maybe this is where a 4 times 18 times 1.5. Let's go ahead and use the calculator. So 4 times 18 times 1.5, that's going to get us 108. Then to get our approximation, what we do now is we're going to take, and remember, this is what we're trying to approximate. So we're going to approximate 2 pi, and then times this integral from 0 to 4 of r f of r dr. Well, this piece here, that's your integral from 0 to 4 of r of f of r dr portion. So we're going to add all of that stuff up, and that's going to get us our portion of our answer from down below here. So we're going to take and add up all of those values. Again, you got a calculator, so you might as well use it when you can. So 2 plus 12 plus 12.5 plus 108, and we get out of there 134.5. That was what our approximation of the integral portion of this was. But remember, we still need to multiply it by 2 pi, so then we're just going to take that answer, we'll multiply it by 2 pi, and then out of there we're going to get 845.088. They usually want you to kind of round things on your final answer to 3 decimals on an AP Calc test. So that is our final answer for our approximation of what this integral is. And so maybe at the end, to kind of make sure you're clear with them that you knew what you were doing, you would say 0 to 4 r f of r dr is approximately, put your little squiggly equals, 845.088. So whenever I'm doing a Riemann sum, like I said, off of a table, I like to go ahead and put it into a number line to begin with. It helps me digest the material quicker. And then I break it into bite-sized little math problems. And once I have all those little answers, that gives me my approximation. And in this one, it just had that one additional piece of being multiplied by 2 pi. Put that together and get your final answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.